60 grams of a radioactive isotope was produced in an experiment. The rate of decay of this isotope is known and can be modelled by m is equal to 60 e to the negative 0.15 t, where m is the mass of the isotope and t the time in hours. Find to the nearest minute when the mass of the isotope remaining is 30 grams and then 10 grams. So that's m is 30, so here we're going to solve 30 is 60 e to the negative 0.15 t. So what does that give us? So action advanced solve, and then I'm going to put 30 equals 60 times e to the negative 0.15, and I'm going to use x rather than t. Remember, we solve automatically for x, but if we want t we have to tell it. So execute, and that gives me 4.62. So that's 4 hours, since the time was in hours, and then if we do 0.62 times 60, that gives us 37 minutes. Now for 10 grams, we're just going to solve 10 equals 60 e to the negative 0.15 t. So let's just change that one to 10. And that's 11 hours. And then 0.945 times 60 gives us 57 minutes to the nearest minute. What is the rate of decay initially and when the mass is 30 grams? So dm dt is going to be 60 multiplied by e to the negative 0.15 t. Now that's because the exponential doesn't change when we differentiate, but we now have to multiply by the differential of the inside function. So we have 60 times 0.15, so that's going to be negative 9 e to the negative 0.15 t. So initially is when t equals 0, so we've got negative 9, and that seems to be in grams per hour. When the mass is 30 grams, so we want dm dt, when t is, and we had the solution to this, and unfortunately I wiped it off the calculator, so I'm going to have to go back and we can very quickly edit this, make that 30, and solve that again. And it's 4.62, so let's just use 4.62 here. And so we have negative, now I have to use the other negative at the start, always trying to remember that. So that's negative 9 multiplied by e to the negative 0.15 times t, which is the 4.62, and that's negative 4.5 grams per hour.